There are a lot of space objects all around the universe, from stars to planets to satellites, comets, and asteroids. But our closest celestial body is the Moon, which has been subject to much research, theories, and even myths. As our only natural and permanent satellite, the Moon is in the top 10 list of biggest satellites in our solar system. It's located in an outer spiral arm of the Milky Way galaxy. Other planets in our solar system, like Mars or Jupiter, have many other moons. Saturn is the planet that tops this list, with an astonishing 82 moons, of which 53 have names. Shall I go through that list of names? No? Okay, we'll move on. Our moon, with its mean radius of 1,079 miles, isn't the biggest moon in the solar system, but is the largest compared to the size of the planet it orbits. The difference between a satellite, like the Moon, and a planet isn't their size, although that might be your first thought. The largest moons in our solar system are really huge. Some of them are even bigger than planets. Jupiter actually has a bunch of these types of satellites, like the icy Ganymede. It's the largest moon in our solar system, larger than Mercury and Pluto. It may even have an underground saltwater ocean that can surpass all the water on Earth's surface. Our moon's diameter is a bit larger than a quarter of that of the Earth. When it comes to mass, though, it's 80 times less than our Earth's. To paint you a better picture, if you think about our planet as being a big hollow balloon, you would need about 50 moons to fill it. But let's look at our moon's size from a bit of a different perspective. How does it compare to the United States? Well, the US measures 2,800 miles wide horizontally, which means the moon is smaller in diameter. It's difficult for us to see it any other way, but what if our satellite was twice as big? Well, first, we would see way more of those solar eclipses. In present conditions, they can happen 2 to 5 times a year, and 5 times is more of an exception. The last time there were 5 solar eclipses in a year was back in 1935. You'll have to wait until 2206 to see the next event like this. I might be around for that. If the Sun and the Moon look about the same size from down here on Earth, but I guess it won't be a surprise if I tell you the star we're orbiting around is enormous. So if the Sun was hollow, how many moons do you think you'd need to fill it up? Wait, no need to Google. You would need 64.3 million Earth moons, or about 1.3 million Earths. Yep, it's that huge. And while we're on the subject of our Sun, it has a diameter of 864,000 miles. Its mass? Well, it's no less than 330,000 times bigger than that of the Earth. What is a star, though? I'm not a scientist here, so I'll try to keep it simple. It's a ball of bright, flaming hot matter held together by gravity. The reason why they give off both heat and light is that, well, they are very hot. Experts call the smallest stars red dwarfs because of their size and color. They're also the most frequent types of stars in our galaxy, with some of them being so tiny and dim they are invisible to people on Earth. It's the case of our nearest neighbor star, Proxima Centauri. Our Sun is considered a medium star since it has an average mass, brightness, and life expectancy. There are also giant stars out there. They are rarer but easier to see. That's why you can safely assume that roughly every star you see after the Sun is set is much larger than the Sun. But enough about it. Let's bring it back to the star of today's show, the Moon, our only natural satellite. But is it? That may or may not be the full truth, actually. Back in 1997, a group of scientists stumbled upon an asteroid about 3 miles wide, looking like it was caught in Earth's gravitational grip. It looked like a satellite of our planet. They called it Crunia. It takes this guy about 770 years to make a trip around the Earth. It also seems that it will remain in a suspended state around our planet for at least another 5,000 years. The Moon is also kind of steering away from us. With each year, it essentially holds up some of our planet's rotational energy and uses it to launch itself about 1.5 inches higher in its own orbit. If the data we have available today is correct, back when it was born, our Moon was about 14,000 miles away from us. The distance now is 239,000 miles on average. So, what will happen when it moves away completely? Well, no more songs like Moon River, Fly Me to the Moon, How High the Moon, that's for sure. Then there will simply be no tides in our planet's oceans, and our nights would become darker. The seasons would look a lot different, and so will the lengths of our days. Based on current calculations in the science world, this will take about 50 billion years or so. So there's no need to rush out stocking up on flashlights just yet, unless you just like to hoard stuff. There's also another catch here. Our sun gets about 10% brighter every billion years. I'll spare you the calculations, but to sum up, it's more likely that long before the Earth will be left without its moon, the sun will have already swallowed them both. Gee, I don't find that any more comforting. But hey, what makes a planet, well, a planet, and why isn't our moon considered one? I mean, it's bigger than some other objects in our solar system, which are technically planets. For starters, a planet is a celestial body that does three things. It orbits around a star, not something else. It is massive enough to become roundly shaped because of its own gravity. And lastly, it has the power to snatch up any dust or fragments in its orbit as it continues to move around the sun. So, we've established that the moon doesn't orbit the sun, but it doesn't really orbit the Earth either. Both of them orbit a certain point stationed between them called the barycenter. It's about 1,000 miles below the surface of Earth, sure, but still some 3,000 miles from the center of our planet. Since this barycenter lies beneath the surface of Earth, we do not consider the moon a planet. To be able to do so, the moon would have to be either about a third larger or a third further away, so that the barycenter would be independent of Earth's surface. The moon does have some other planet-like characteristics, though, which makes it very special in our solar system. Firstly, it has a crust, a mantle, and a core. It also has quite an active geology, with events like our own earthquakes. You guessed it right, they're called moonquakes up there. Hey, do they have moon pies up there too? Nah, come on. Let's continue our space exploration a bit more. Wait, what? You can't hear me? Of course you can't, because space is utterly silent. Since there's no atmosphere in space, sound has no medium or way to travel for you to hear it. You will want to steer clear of Venus if you do wish to continue your outer space travels. It's the hottest planet in our solar system. It has an average surface temperature of around 840 degrees Fahrenheit. Hot! You'd think that's because it's closest to the sun, but it's not the case. You would also think that the closest planet, Mercury, would then be the hottest. Well, since this one has no atmosphere that would help regulate the temperature, it tends to have bigger fluctuations. Your calendar would also be very messed up on Venus, since one day on its surface is about as long as a year on Earth. That's because Venus is rotating slowly around its axis, taking 243 Earth days to complete its own day. If you were to pit stop on Mars, be on the lookout for those blue sunsets. According to NASA specialists, there is some fine dust that makes the blue near the sun's part of the sky much more visible on Mars. Any diamond fans out there? Pack your bags, because there's a planet out there made of diamonds, and it's twice the size of Earth. They believe it's mostly covered in graphite and diamond. A spacesuit costs about $12 million, but a visit there would cover the expenses altogether, don't you think? And if you're not a fan of space explorations and prefer the comfort of our planet, here's some good news for you. We have more trees right here on Earth than there are stars in our galaxy, the Milky Way. We know there are about 3 trillion trees here on planet Earth, and between 100 and 400 billion stars in our galaxy. Sometimes when you look at the moon, you see a face smiling down at you from the moon's surface. Of course, this is an illusion, but many people see it, and that's because its surface is shaped by some sort of lunar seas and highlands. From our point of view, we see these as light and dark patches. These seas are dark parts, and large hardened lava plains formed because of volcanic eruptions that happened a long time ago. The light regions are actually the mountains and the highlands. And people all around the globe see these lunar patches as a smiling face or even some other shapes. Our brain tends to play with things of this nature, and that's a phenomenon called pareidolia. It's when you see familiar faces and shapes even though they're not actually there, similar to how you can see a face in a slice of toast or shapes while watching the clouds. And in the northern hemisphere, people see a face in those different lunar seas. The eyes are the Sea of Serenity and Rain, the Sea of Clouds represents his mouth, while the seas of islands and vapors form his nose. But that's just one way to interpret this picture, and that mostly works in the northern hemisphere. If you live in the southern hemisphere, you see the moon the other way up. When they look at the moon, some see a person that looks like they're carrying a bundle of sticks. Or there's the shape of a woman. She wears her hair up and it has 2 jewels in it, and they see the left side of her face in profile. One of the craters is reminiscent of a shining diamond which, it seems, she's wearing around her neck. In some places, people may see the shape of a rabbit, whereas people from the Pacific Northwest in America even have a story about the toad they see when looking at the moon. The story says there was a wolf that fell in love with a toad, and the toad didn't quite trust the wolf since it wanted to escape and didn't know where. It simply made one huge leap and landed on the moon. Now, do other planets have beautiful rainbows like we do? The ingredients for that are raindrops and sunlight. At the moment, we don't know of a planet with liquid water on its surface, and none have enough water in their atmosphere to make it rain. But droplets of some other liquid could refract light coming from the sun and spread it out into various colors. Titan is one of Saturn's moons, and the atmosphere there is rich in droplets of liquid methane, which probably form rain. The atmosphere on Titan is very hazy. That means that direct sunlight is not that common, but there's still a slight chance we could catch methane rainbows someday. If they really exist, they'd be similar to rainbows on Earth, but they'd be a bit broader because methane refracts light differently than water. There's a similar thing on Venus called glory. Scientists caught pictures of this optical phenomenon of sunlight falling on sulfuric acid droplets, similar to a rainbow. Jupiter is insanely big, around 11 times wider than Earth. Not only that, our planet is twice as small as its Great Red Spot, the raging storm that's been present on the planet for more than a century. Now, we owe Jupiter a lot. Its radiation is 1,000 times stronger than the lethal level for us, and the gravitational force is so powerful that it actually protects our planet from collisions. In some other planetary systems, giant planets like Jupiter can move around and migrate from the place where they were originally formed. They spiral inward and get closer to their stars. When they move around, they can cause a lot of trouble. When they get closer to their stars, they can swallow and destroy some innocent small planets or other celestial bodies that stand in their way. But if these giants remain far away from their stars, they serve as guardians of the planetary system. They protect the planets in the inner orbits and allow them to circle around a central star. Jupiter got the nickname vacuum cleaner of the solar system because it can eat up any comet or asteroid that comes close enough. It can also change their orbits and kick them out so they can't come back for a very, very long time. That way, Jupiter protects the inner planets, although sometimes it accidentally sends asteroids or comets into them, causing collisions like maybe the one that made the dinosaurs extinct 65 million years ago. Now, Saturn's rings are the most famous ones in our solar system. They are far-reaching, colorful, and highly visible. You can even see them using a backyard telescope. But some other ice and gas giants also have them too, like Uranus. It has the second most interesting set of rings in our solar system. There are 13 rings, and they're all made of very dark particles that are different sizes. They're most likely young, way younger than Uranus itself. One theory says high-speed impacts shattered one or more moons, and this may have been the matter these rings are formed of. There were way more particles of debris, but only some survived, and today are forming stable zones around Uranus, known as rings. Now, our planet lost 60% of its atmosphere when there was an asteroid impact that, as one theory says, probably created the Moon. The collision between Earth and a Mars-sized rock happened over 4 billion years ago. The debris from all that, collected in an orbit around our planet, eventually formed the Moon. Now, Venus is home to at least 37 volcanoes that were active recently, which is the first evidence that showed its interior is still geologically active. Previous research discovered that the planet's interior was warm, plus there were ring-like structures. Plumes of extremely hot material deep inside Venus rise through the mantle layer, and that's how these structures form. It's like how plumes form the volcanic areas of the Hawaiian Islands. But scientists think they were just a result of some ancient activities. They believe Venus has cooled enough and drastically slowed down geological activities in its interior by hardening the crust so much that all of the warm materials from deep inside can't get out to the surface. Speaking of volcanic eruptions, Jupiter's moon Io also has them. Our moon is pretty peaceful, but Io has hundreds of volcanoes, and it took the title of the most active moon in our solar system when it comes to volcanoes. If you could go there, you'd see plumes of sulfur that reach up to 190 miles into its atmosphere. Volcanoes there emit 1 ton of particles and gases into space near Jupiter, its parent planet, every second. This could be because Jupiter's strong magnetic field and gravitational force. Io's interior tenses up and relaxes as it orbits Jupiter and gets closer to it and farther away from it, which generates huge amounts of energy, enough for volcanic activity. There are billions of comets in our solar system. Most of them are in the Oort cloud and the Kuiper belt. A comet generally consists of rock and ice, at least until it gets closer to the Sun. Then its exterior turns into a cloud of dust and gas, and that's why comets have their specific tails. Pluto's unique surface is a series of domes, peaks, and troughs on the planet's landscape, which may have been formed because of its many large ice volcanoes. Neither erosion nor some other geological activity has done that much, but its ice volcanoes actually push icy material up to the surface. There are also a couple of craters in this area of the hemisphere called New Horizons. Asteroid impacts probably caused these. Plus, these craters aren't that geologically old. Also, the interior of Pluto probably retained heat, which enabled matter rich in water and ice to deposit onto the surface. And those specific structures I mentioned before could have formed because the water was rising up from the interior of the planet and ended up being rapidly frozen because temperatures on Pluto are extremely low, in addition to atmospheric pressures. Uranus is the second least dense planet in our solar system. The least dense one is Saturn. Now, even though Saturn is 14.5 times as massive as our planet, it's still less dense than water. This means that Saturn would float in a pool if it was more than 37,000 miles wide, so the planet would have enough space to even be in there. Whoa, that's a big pool. Now back to Uranus. Since its density level is so low, you probably experienced less than 90% of its gravity, assuming you could even set foot on its cloud tops. Now Mars has pretty crazy dust storms, the biggest ones in our solar system actually. They can blanket the whole planet and last for months. One theory says these huge storms start because dust particles absorb sunlight and warm the atmosphere of the red planet. Warm pockets of air form, and they start flowing toward colder areas. This generates winds. These powerful winds lift more and more dust off the ground. This again heats the planet's atmosphere, creates more wind, and kicks up even more dust. Wow, better have a broom handy, maybe even two. Have you ever seen the other side of the moon? I caught you. Of course not. But maybe you've seen it in photos. In that case, have you ever wondered why the two sides look so different? Well, let me tell you. We can't see the other side of the moon. People believe this is because the moon doesn't rotate around its axis. But this is not true. The moon does rotate. It just does it at the same rate as its orbital motion. This is a particular case of tidal locking called synchronous rotation. The first time we ever saw a far side was only in 1959, all thanks to the Soviet Luna missions and later the US Apollo program. Now, when Luna 3 and other spacecraft transmitted the first far-side images, they revealed a far more cratered hemisphere that looked more like Mercury or Jupiter's moon Callisto. It looked completely different from what we were used to, and that's when we learned how meh the other side is. No, seriously, just look at it. The near side can boast its thinner and smoother crust. These beautiful dark splotches are called lunar mare, the last remnants of ancient lava flows. And when I say ancient, I mean it. They're more than 3 billion years old. Meanwhile, the far side crust is thicker and crater-pocked. The lava flows had almost no effect on these impact craters. It's also devoid of any large-scale mare. Low-key looks like dried white cheese. To be honest, don't you agree that the nearby side is much more beautiful? Write your thoughts in the comments. So, only 50 years ago, we learned something about the apparent differences. But then the scientists discovered something weird. Both sides are different, even in the geochemical composition. And not only in this, our side was thinner than the far side by several miles. But where did such significant differences come from on an ordinary floating stone ball? For scientists, this was a mystery. They started coming up with a lot of theories. The melted moon theory was the main one for a while. It said that it was the Earth's fault that our moon looks like this. This happened several billion years ago. The moon was born because of a collision. One day, an object about the size of Mars crashed into the Earth. At that moment, a piece broke off from it, which later became the moon. However, this piece was somewhere 15 times closer to Earth than it is now. Some scientists created pictures of the so-called early moon. Unlike our cute little white ball, the early moon was a strange-looking, boiling scarlet ball. That piece didn't leave us after the separation. It became tidally locked very soon after. The Earth after the collision was still an incandescent nightmare, full of fire and lava. It was boiling at a temperature of 4,500 degrees Fahrenheit, and since the moon has always been turned toward us with one side, this side has melted down a little. This would explain why the moon's surface, the so-called mantle, is thinner on the near side than on the far side. During the boiling of the Earth, certain elements evaporated from it. They then settled on the moon. This would explain the difference in geochemical composition between the two sides. But there was a plot hole in this theory. If that's what happened, then where did rare foreign chemical elements come from, such as unusual isotopes of phosphorus, potassium, or tungsten? The nearby site is full of them, and they couldn't have come from the Earth. There were also other theories. Another one said that initially we had two teeny-tiny moons. Later they merged into a big one, hence the difference in their composition. But this theory sounds a bit crazy, and it has a plot hole too. For example, the transition between the two sides is way too soft. If our moon was actually two tiny moons, this transition would be more abrupt. So scientists were kind of at a loss on this one. But recently, they finally figured out what really happened to the moon, all thanks to NASA's Grail orbiters. They spent over a year whizzing around the moon, mapping it out, and studying its composition. Using this data, scientists have created around 360 computer simulations. They contain different impacting objects of many sizes traveling at different speeds. Scientists were comparing the results with our current moon. They tried to determine which result was the closest to what we have today. And so, they finally solved this 50-year-old mystery. The answer lies in a collision with a dwarf planet. This collision occurred 4.3 billion years ago. This huge object was slightly larger than Ceres. For those who don't know, Ceres is one of the dwarf planets of our solar system. Its diameter is 580 miles. You could say that one France or one Germany would fit into it. So, this giant object crashed into the moon, somewhere near the South Pole. This collision was so strong that it changed the image of the moon forever. It left a trail of 3,500 miles behind. It would take you 14 hours by plane to fly that distance. This crater covered the entire near side of the moon. It caused damage to the moon's mantle. It also created a so-called South Pole Aitken Base, or SPA basin. This is an impact crater and has a diameter of 1,600 miles, which is like adding one UK plus one Germany. It's important though. The formation of this basin was a defining event in the history of the moon, and it's the second largest impact crater in the solar system. The collision also caused a powerful hot wave to spread across the moon. This wave scattered over the remnants of those rare warm minerals scientists found on the nearby side. That's how our beautiful side became home to something called Procellarum creep terrain, or PKT for short. This is basically a compositional anomaly, a concentration of potassium, phosphorus, and other rare elements like thorium. You can say that those minerals are a gift to us from deep space. Anyway, there were many, and I mean many, collisions in the Moon's history. All of them only deepened this already large crater. That's why the mantle on the near side was getting thinner and thinner with the years. Also, our gifted minerals gave off a lot of heat, so the mantle has melted a little bit more and more. Oops, this accidentally caused the Moon's volcanoes to wake up. Volcanic activity has increased on the near side. Intense lava flows filled the old empty craters. Ta-da! And this is how the beautiful lunar mare was born. That's about how it all happened. All this information was found thanks to the researchers from Brown, Purdue, Stanford Universities, and NASA's JPL. The research was published by the Journal of Geophysical Research, Planets, so you can read about it in more detail if you're interested. There are still many things we need to learn about the Moon. The highest priority is the return mission from the South Pole, the Aitken Basin. Samples brought from there will be used to determine the age of the Moon, its history, and the nature of the crust and mantle more accurately. Another critical target is the Moscovians. This is the name of a large lava plain on the far side of the Moon. Studying it will help us better understand the difference between the two sides, as well as tell us how the other side was formed. All this knowledge is significant for understanding the history of the Moon, but it's also handy for space exploration in general. Scientists use the Moon as a reference point to determine the age of other planets and entire worlds in space. The Moon helps us determine the chronology of the life of the whole solar system. So, stay tuned for new exciting research and discoveries.